Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So today's question is minimum same difference. In this question, for an array A of size n, we define f of A as follows. So if A contains n distinct elements, so if all the elements of array A are distinct, then f of A is straight away 0. Otherwise, f of A is defined as the minimum of j minus I among all the pairs I comma j which satisfies A of I equal to A of j. So for example, if we have an array 1, 1, 1, 2, 2, 1, 3, 3. Then, for all the pairs satisfying A of I equal to A of j, f of A is minimum of j minus I. That is the minimum distance between the equal pair of elements. So for this array, these two elements are equal and they have a distance of 4 minus 1, that is 3. And these two elements are also equal and they have a distance of 6 minus 5, that is 1, which is the minimum in this case. Hence, f of this array is equal to 1. Now our task is to find the sum of f of A over all the arrays A of size n satisfying this condition. So we are given two integers n and k, and we can create all the possible k to the power n arrays, which are like if n is 2 and k is something, then we can create 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So these are all the possible 9 arrays, which is 3 square, which we can create. And we need to print the sum of f of A over all such arrays. And since the answer can be very large, we need to print it modulo this number. Now, the constraints we are given that the number of test cases will lie in between 1 and 10 is to the 4, and n comma k will lie in between 1 and 2 into 10 is to the 5. And it is also given to us that the sum of n over all the test cases would not exceed 2 into 10 is to the 5. So now let's move to the sample inputs once. So the first input are n is 2 and k is 1. So the only possible array is 1, 1, and f of this 1 comma 1 is equal to obviously 1, right? In the second array, we are given n equal to 2 and k is also equal to 2. And the only possible arrays where we'll have some f of a would be these two. And both of them have f of a equal to 1. So the total sum is going to be 1 plus 1, that is 2. The third one you can calculate by yourself. The fourth one is n is just 1 and k is 5. So you can easily see that the only 5 possible arrays would be 1, 2, 3, 4, 5, and f of a for all of them would be 0, right? So the total sum is also equal to 0, and hence the answer is 0. Now the last case, obviously it's just for testing, so you can just implement your code and test it on this test case, and let us move to the solution. Now first of all, it's very, very obvious that we cannot create all the possible arrays because there could be k to the power n arrays and k and n are already very huge. So we'll have to use some combinatorics or something, right? So let us begin by defining the C of x as the number of arrays A with f of A equal to x, right? So what is C of x? It is the total number of arrays that we can create, which will have f of A as x, right? And how many such C of x can exist? That would be n minus 1, right? Because if we have n elements, then the maximum distance between any two elements would be n minus 1, right? Which would be in between 1 and n. So the maximum possible distance could be n minus 1. So for all those n minus 1 possible values, we'll calculate how many arrays exist, right? And this is a rather simpler task in terms of time complexity, right? Because we can calculate, like we can actually think of calculating this. So if we have calculated g of x efficiently, then the answer would be simply the summation of x, that is the f of this, f of a, times the number of such arrays that can exist, right? Now, how do we calculate g of x, right? The most important part of the question. So for some x, right, for like, we're just trying to see what are the conditions to calculate g of x. So for some x, we want the array to have j minus x I greater than equal to x for all the pairs where a of I is equal to fj, right? That is the first condition, because if it is lesser, so if we have any pair 1 1 or any other pair which have a distance of j minus I which is less than x, then the whole array would also have the f of a is less than x, right? But we want it to be equal to x. So we want all the pairs, right? So if there is 1 1 and there is 2 2, we want all of them to have a distance of at least x, right? and there must exist some pair j minus I which is equal to x. Right. So if all the pairs are greater than x, then the f of a would also become greater than x, right? So we want that there should be at least one pair, I comma j, which have j minus I equal to x, and rest all the pairs must have j minus I greater than or equal to x for all the elements a of I equal to a of j, right? I hope this makes sense. So now let's try to compute this c of x for some particular array, right? So let's say we have n equal to 7, k equal to 4, and we're trying to calculate for x equal to 3. So we'll, like, using combinatorics, what we'll do, we'll try to make these two elements equal, and we'll try to have all the other elements have a distance of greater than x. Then we'll try to make that these two elements have a distance of x, and rest all elements have a distance, all the equal elements have a distance of greater than x, right? But would we be able to compute this way? So even if we apply combinatorics, one big challenge in computing this way would be that, let's say we made these two elements as equal, right? These are equal. Then in the next, we made these two elements as equal. But the case where these two elements are equal, as well as these two elements are equal, right? As well as these two elements are equal, those two arrays would be counted twice, right? And there would be many more such scenarios where multiple counting would happen if we define it this way. So it would be very hard to calculate it this way in short, right? So what instead we'll do is we'll count the number of arrays for some x in which every pair of equal elements have a distance of at least x. So basically, instead of ensuring that these two elements are equal, we'll just ensure that this particular first condition, right? We'll just ensure this first condition that for any equal elements, the distance between them would be at least x instead of equal to x. So what that will do to us is, so like we can easily calculate this thing first of all. Now, if we are able to calculate it, how would it help? So I'll just discuss that first. So we're going to call this thing as d of x. So the number of arrays for some particular x which have for in which for every pair of equal elements have a distance of at least x. That is basically this first condition, that for any two equal elements they would have a distance of at least x. So, and that is called d of x, right? So how would we be able to calculate c of x using this d of x? So d of n would contain all the number of arrays which have a distance of at least n, and d of n minus would contain all the pairs, all the number of arrays which would have a distance of at least n minus 1. Now, what if we do d of n minus 1 minus d of n? It would be the number of arrays which have a distance of at least n minus 1 minus the number of arrays which have a distance of n. Right. So, what would we get? The number of arrays with a distance of equal to n minus 1, right? Exactly n minus 1. Similarly, d of 3 and d of 4 would contain the number of elements which have a distance of at least 3, right? Where every equal pair of elements have a distance of at least 3, and this have at least 4. So if we do at least 3 minus at least 4, we'll get exactly 3, right? So this way we can compute all our C1, C2, C3 dot 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 till Cn minus 1. And once we have computed these, we can easily calculate our answer as well, right? Now the only task is how do we compute this array D. So for that, let's say these are some conditions which we just use to calculate the formula for calculating D. So let's say n is 7, k is anything, doesn't matter. X is equal to 3. So we're trying to calculate for x equal to 3. How would we calculate? So for the first element, we have k options to put down, right? There's no constant, we just put anything, whatever we want. For the second element, we have k minus 1 options, right? Because these two cannot be equal. Because if they are equal, then x is equal to 1, but we want it to be 3. Now, again, for this, we have x minus 2 options because these two cannot be equal. These two cannot also be equal, right? For this, how many options do we have? We have k minus 2 options again, right? Because these two cannot be equal. These two cannot be equal, but these two can be equal because they'll have a distance of uh, 3, which is allowed, right? Because 4 minus 1 is 3 and 3 is allowed. And even if it's not, even if they're not equal, then we might have some distance bigger than 3 in the future. Now, how many options do we have for this element? These two cannot be equal. These two cannot be equal, but rest it can be anything. So it cannot be equal to these two elements. So we have k minus 2 options, except these two, right? And similarly, for all the rest of the elements, we'll have k minus 2 options only. So how many total options do we have? K into k minus 1 into k minus 2 into k minus 2 raised to the power 4. Or we can rewrite it as k into k minus 1 into k minus 2 raised to the power 5. Right. And if we notice, then this 5 is nothing but n minus x minus 1. That is the total number of positions that we had minus x minus 1. Right. Now, how do we compute it for some general, right? So yeah, for some x equal to a, so let's say this is the ith index. So for the first we have k options, then k minus 1, then k minus 2, and dot 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 up till here we'll have k minus I minus 2 options, right? And over here we have k minus I minus 1 options. Alright. And similarly for all the rest of the elements we'll have those many number of options only. So what is the count of these elements? This is n minus x minus 1 as we discussed here. Right. And what was the element up till here? I minus 2. Right. This thing. So k into k minus 1 into this. Right. And this is pretty much the whole formula for d of x. So we have found the formula to calculate d of x. Now let's just once verify it for x equal to 4, just a sanity check to see if our formula is correct or not. So yeah, if our x is equal to 4, then there are like k options for the first index, k minus 1 options for this, k minus 2 for this, k minus 3 for this, right? Because these and these cannot be equal. And all right, these two can be equal, right? Or they cannot be, yeah, they cannot be, my bad. So these two elements can be equal. So we have k minus 3 options for this. That is not this, not this, not this, but rest everything can be there. So k minus 3 options for this, k minus 3 for this as well, k minus 3 for this as well. So in total we have k minus 3 raised to the power 4 into k minus 1 into k minus 2. Right. Now checking if like what do we get from this formula. So if we put x equal to 4, so we'll have okay, so yeah, anyways. So here it would be k minus 4 minus 1, that is k minus 3, k minus 3 raised to the power n minus n is 7, 7 minus 4 minus 1, that is 7 minus 3, that is 4 only. So we get a 4 only over here. And then I minus 2, that is 4 minus 2 is 2. So k into k minus 1 into k minus 2, that is exactly what we got over here. So the formula is correct, and that's pretty much the whole solution as well. Rest is just compute C and calculate the answer. Now, what would be the time complexity? It would be n log n. Why? Big O of n for running a loop and log n to calculate the exponentials, right? Now, don't forget to take modulo mod everywhere. Otherwise, you just make a wrong answer. And yeah, that's pretty much the whole solution. Now, let's move to the solution as well. So yeah, this is the solution code in C++. So we take in the input of n and k, we define the vector d, we calculate everything. So over here it is just the binary exponentiation part, and over here this is the current product which we are maintaining using a variable. So every time it is initially 1, then it would be k, then it would be k minus 1, k minus 2, so k into k minus 1 to k minus 2, and that's the current product that we are maintaining. Then we're just calculating the answer using C of I and the answer. So yeah, that's pretty much the solution. Now let's see the solution in Python. So we run a loop for all the test cases. We take in the input of n, k, we define the vector in the list d. Over here, we calculate the d of I for every variable. So this is the power thing, that is k minus x minus 1 raised to the power n minus x minus 1. And we're just maintaining a current product. So it would be initially 1, then k into k minus 1, then k into k minus 1 into k minus 2, and so on. This will just simply calculate the current product and the powers. Then we'll just simply calculate the C of I. And using this C of I, we'll calculate our answer and we'll just simply print it. And yeah, that's pretty much the whole solution. The time complexity again is n log n, big O of n in general, and log n for calculating the exponentials. And yeah, that's it. I hope you liked it. Thanks. Bye bye.